Okay, here's our Module 1 introduction. And in Module 1, we're looking at distance. And just to show why, why is this complicated? Okay. Well, these are the kinds of things we want to look at what do we need to do in different situations? So we'll answer this question of why it's complicated by looking at some different situations. So typically, if I just want to know what's the distance from here to here, I would just go in here and I would measure. Okay, I'd get out my tape measure, I'd get out something else, and I'd just measure and I'd get this distance. And this distance, this straight line distance from point to point here, we call the Euclidean, try that again. This is called our Euclidean distance. And it's the kind of thing we're used to, is just measuring that straight line distance. Now, even that can get a little complicated because, well, it could be I can't always just actually measure that. And so, it may be that we've defined a grid somehow, a Cartesian coordinate system, and we have a point here that we'll call maybe the point AB, and another point here that we'll call the point CD, and we'll want to know that distance. Well, it could be that I know the coordinates of those points. Like, I can go out and I've got, say, some sort of GPS device or something like that, and I can tell you exactly where I am. But now, what was that distance? And, well, I guess you could say, well, use your app, right? But again, what's the app doing? What's going on? And we want to understand, sort of what's going on. So in a flat plane, well, what we use is the Pythagorean Theorem. And so if I, call this leg 1 here, and this one leg 2, and this the hypotenuse, h, Pythagorean Theorem, for right triangles, and this is a right triangle on this grid, would say that if I take L1 squared plus L2 squared, I get h squared. So the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. So that's a nifty understanding of geometry. That's a nifty theorem to have. And, well, then how do I get leg 1? Well, that's the difference in the x coordinates. So that's c minus a. And so the Pythagorean theorem would say, well, I take c minus a and square that plus this L2 here, and that is the difference in the y coordinates, so d minus b squared, and I'll get my distance then, the distance I want, squared. And so my distance, using the Pythagorean theorem, is the square root of my difference in the x coordinates squared plus my difference in the y coordinates squared. So on a grid, on a map or something like that, where I know coordinates, I can use the Pythagorean Theorem. Okay, great. End of story? No, here's the problem. Okay, those same 2 points, here's this point, what's the distance? Well, unfortunately, one scenario is that actually there are a bunch of buildings in the way. Okay, there are all these buildings, and I'm in a car, and I have to go by streets. And so I go down, First Ave here for a little way, and then I go on North Boulevard. What the heck? Boulevard. For a little way. And that's now my distance. Well, to say that it's this far is misleading, right? If I use that hypotenuse, it's misleading. So I really need to go on the city streets, and that's a different sort of distance. We still will call it a distance, but it's a different distance. It is not the same as going straight from point to point. I am stuck going on this grid, and so we tend to call this, since I'm stuck on a grid, looking at the distance this way, that's either you can call it grid distance, we'll call it grid distance at times, but we'll also call it a taxi cab distance. And there are other names for it as well, but this grid distance, where I'm stuck on the grid or taking a taxi cab on a grid, that is another way to measure distance. And you can see that if I have all these, if I'm stuck on city streets and so forth, then I really am stuck to using the distance here. I really am stuck on those streets. But again, here are the points, and now I'm out in some rural area, and of course city streets could do some things like this as well, but well, here's a big lake, and in order to get from this point to that point, maybe I have to take this route, and well, there's the lake, and here's a big hill or something like that. That's a hill. Great job there. But now you see I have to take the distance along this path, and so I'm going to call this like a map or path distance. So it's related to both Euclidean and grid distance in that certainly if my path went straight from this point to that point, that path went straight there, then following the path distance would be exactly the same as the Euclidean distance. It'd just be a straight line distance. Great. Okay, but it doesn't have to be, as we see from this path. Similarly, if that path had to go along a grid that we had thrown over top of all this and was making, nice right turns and left turns and all that kind of stuff at 90 degrees and made that nice grid, then it would be the same as the grid distance to get there. But in this case, well, it's kind of neither. Any small spot might be a grid distance or a Euclidean distance, but the path on the whole, right, it's this kind of curved thing that goes around, and so we'd have to measure that path. Okay, well, so there we go. There's another very reasonable way to measure distance for the context of a problem, right? If I have to go from site A to B here, then, even though that distance maybe isn't that far. Well, to actually get there is kind of a long distance. And so, you know, it's not the same as the other two. So now I've got three possible ways I might measure distance. Well, we can add in a fourth quite easily. And here I've got these two things. There's the lake. Here's the path. There's the big hill that we had to go around. Okay, so it could be that, yeah, okay, there's that distance. That's one way of getting there. But it might also be that I could go here, jump on a ferry boat. There's the smokestack. Boats don't tend to have smokestacks anymore, but hey, I'm really old. And so we're taking the ferry boat across here and getting on that way. And it could be that this way, you know, takes a total of 20 minutes. And going clear around this whole thing, whatever it is, you know, maybe this is Lake Michigan. Who knows? Well, it takes a lot longer than 20 minutes to get across Lake Michigan and so forth. But, you know, the idea is that, well, yeah, depending on where you are, though, it could take a really long time to go this way. Maybe this is 90 minutes. And so now here, I'm not really interested in a true distance anymore, as in something measured in feet or miles or yards or something like that. Now, really my measure of distance, or how far is it, is time. And probably you've all done that at some point. You know, how far is it to get from, you know, your home to work? And often you'll tell people, oh, you know, it's about 15 minutes, right? You don't tell them it's 2 miles or 10 miles, right? Because one person for whom it's 15 minutes, it might be 12 miles. But for another person, depending on where they live, to get to work in 15 minutes might only be 2 miles. But see, what we understand is sometimes, you know, it matters what the traffic and the roads and so forth are like. You know, are we getting on an expressway, or are we going through a bunch of city traffic with a bunch of stoplights? And so then all of a sudden here, we're talking time. And so, you know, the distance could be in time. And then, you know, finally, well, it might not be time or real distance, as in yards or meters or miles or whatever. It could be cost in all sorts of things. Could be dollars, right? You know, because you could think of the distance from one point to another being how much it costs to ship things from that point to the other, right? Is that it could be, you know, I need to mail something from Lexington to Louisville, and, you know, what's the cost of the transportation cost of shipping it? You know, so it could be in dollars, it could be in energy, right? It cost you energy to make something happen. So, you know, etc. So this is the thing, is that really when we talk about distance, you know, our immediate idea is this Euclidean distance, but it might be that, well, we really need to talk about it, say, along a grid distance, like taxi cab distance, because we're on some sort of grid. Well, but it might not be exactly a grid, and we need to start talking about a map or path distance. But even then, it could be a little more complicated because, yeah, there may be more than one way from getting, from this point to this point over here. And it may be a difference in distance, but it may not be. It may be a difference in time, or energy or cost in dollars or something like that. So, again, looking at ideas of dollars and energy, just think of gasoline, right? I could go from point A to point B, and, I could take the expressway and, maybe be driving 70 miles per hour, which gets me there in a shorter time than, say, if I go in this other route. So here's, like I-65 or something like that. But here is, maybe state route, 31, I think, is over by I-65. And I'm going from one to the other. Well, because of the different speed limits and so forth, these two distances could be the same or almost the same or something like that. But if you look at time, I-65 is probably quicker in terms of time. But if you start looking at dollars or energy because of fuel costs, State Route 31 might be cheaper because you're going slower, so you have a little better fuel economy. And so you see, this idea of distance is not straightforward. I mean, it's straightforward in the idea it's some sort of cost for getting from one point to another. Okay, so we're going to look at distance not in terms of feet or yards or miles or something like that, but our distance we really think of as a cost of getting. Now, cost could be in anything. Again, it could be in miles, it could be in dollars, it could be in hours, but cost of getting from one point to another. And that is what we mean by distance. And so you see in context that cost could be measured very, very differently. Okay, so that's why we need to really look at this idea of distance.